Hey, it's Mr. Kingsbury. Just wanted to do some examples of completing the square for you. I'm going to do two different things. First is, I'm just going to find that constant that allows a trinomial to be a perfect square trinomial and then factor it. So we'll walk through that, and I'll do several examples. They will probably get shorter and shorter as we go along, just because I want to streamline the process as much as possible. And then I will show you how to solve using completing the square. So without further ado, let's just jump in this. So let's say that I give you x squared plus 4x. And I want to know what constant we need here so that this is a perfect square trinomial. Remember, perfect square trinomial looks something like this. So the first term and the last term are perfect squares. And then if you square root the first term and the last term and multiply them by 2, you get the middle term. Now, rest assured, I've already taken care of all of that. This is all going to flow real nicely. We're actually given the first two pieces. So what I'm wanting you to do is take this middle piece, divide it by the 2, and actually we'll be dividing it by the square root of this first term as well. It sounds more difficult than it is. And then squaring it, and that gives us this. That's what we're finding. The other possibility is this. It's all treated the same. Really doesn't make that much of a difference. Anyway, I'm belaboring the point. So what goes here? Well, to figure that out, we're going to start with this number. We're going to take that number, we're going to divide it by 2, and we're going to square it. 4 divided by 2 is 2. 2 squared is 4. Now, how do I factor that? I need to find the square root of the first term, and I need to find the square root of the last term. So the first term is x squared. The square root of that is x. The last term is 4. The square root of that is 2. Don't worry about whether there's a positive or a negative. Just take the positive one. So we're going to go x, and I'm going to put 2, and I'm going to have parentheses, and it's going to be squared. And then the question is, do I put a plus or a minus? Well, that depends on the sign of the linear term. In this case, it's a positive 4x, so I'm going to put a positive here. And I know that seems kind of like magic. I'm sorry for that. But hopefully now that I've explained it a little bit, it will make a little more sense. So let me throw a couple more examples at you, and maybe something will stick. So here's example 2. Let's say we've got x squared minus 8x. And then I want to know what goes here. By the way, I don't know if you noticed, but in both of these examples, or both of the general forms, it always ends in plus. That's going to be important. That's why I'm always going to put a plus here, because no matter what I do here, it will always end up positive. When you square a number, whether that number is positive or negative, it always ends up being positive. Anyway, so how do I find my number? I take negative 8, I divide it by 2, and I square it. Negative 8 divided by 2 is negative 4, and negative 4 squared is positive 16. If you get a negative 16, please look at what you typed in the calculator. You probably forgot the parentheses on the outside of the negative 4. So all the calculator did was square the 4 and then attach a negative to the front. Or you put the square inside the parentheses, which you should not do ever. Don't ever, ever, ever do that. It should be typed like this. Parenthesis, negative, number, parenthesis, then the square. Always, every single time. So we get a 16 there, and then we need to factor it. So we need the square root of x squared, which is x, and the square root of 16, which is 4. So this will be x and 4 and squared, and then I use that sign, which is a minus. So I get x minus 4 squared. Let me do about 2 more, and after 2 more, you'll go, this is so easy, Kingsbury. Are you kidding? To which I will reply, no, I am not kidding. It is that easy. So we got x squared plus 8x plus something. I need to find that constant, so I'm going to take my linear coefficient. That's supposed to be an arrow, not a T. 8 over 2 squared, that would be 4 squared, that would be 16. Hey, 16 again. Awesome. Square root of x squared is x. Square root of 16 is 4. So I get x and 4 and a square, and then I put a plus right there, and life is good. So, hey, look, this one was x minus 4, and this is x plus 4. Look at that. And I got to be honest with you. If you don't need to do any of this, then I'm okay with that. I'm not going to be searching your paper for this work. Now, I want to be careful here. I'm not telling you, don't do this. Don't write it down. I'm not saying that. What I am saying is, it is pretty easy once you get the hang of this to be able to take what we've got here and find that number, that constant in your head, or just tap it in the calculator without having to write anything down. And if you know your squares, or even if you don't, you've got your calculator, we've got it set up so it's always going to start with x. And then you just need to know if it's plus or minus, and then you just square with the last part. I mean, I could do it if I really wanted to, because I've been doing this since dinosaurs roamed the earth, but still, I can do it. Let me show you another one. I'll do a couple just to, I don't know, make sure that everything's A-okay. I'm going to do 2 more just for fun. So let's say we got x squared plus 4x, right? So 4 divided by 2 is 2. Hey, this is just like the first one. See, this is why I had another one lined up, because you never know. Let's adjust this. So I guess I'm just doing one more. So we'll do x squared minus 2x plus something. Well, this is kind of not fair because that's pretty easy. I mean, let's be honest. That's a pretty easy one to do. 2 divided by 2 is 1. 1 squared is 1, so 1 would go here. And then when I factor to the square root of x squared is x, the square root of 1 is 1. I put a parenthesis and a square root, and I use the minus. I mean, I didn't write anything over here. And for some of you, you were like, what did he just do? So I'll write it down for you. I took negative 2, and I divided it by 2, and I squared it. So I get negative 1 squared, which is just positive 1. That's what went in here. I square rooted x squared, which is x. I square rooted 1, which is 1. That's what went here and here. I used this right there, and I just squared it. So that's the first, I guess, skill that you're going to do on the worksheet that I'm going to give you. The first, I don't know, 6 of them, you're just doing this. And I don't think it's really hard. And here's the thing, is we want the perfect square trinomial because it factors like this. See, when we write quadratics normally, we've got 2 different binomials that are our factors. And we have a way to solve them doing that, and that's all well and good. But we have to get kind of tricky, and we use this little loophole, or this special, it's a loophole because of a special characteristic of 0. And that lets us solve. Well, with completing the square, because it's the same thing multiplied by itself, we can rewrite it in this form, and this allows us to use the square root, which you will see here in a minute, to cancel out the square and solve. Now, there's still going to be 2 answers, because when you square root, you get a positive and a negative, for the most part. I know I told you to ignore that here, and that's fine. But for the most part, when you square root, you have to look at both the positive and the negatives, and that means then we'll end up with 2 answers. So let me see if I can explain, or I can show you. What I'm getting at ultimately is we're using the fact that the perfect square trinomial has some special characteristics that are not present in any other quadratic. We're using that to help us solve. And what we just were doing was a part of that. We have to be able to make something that is not a perfect square trinomial into a perfect square trinomial to then take advantage of that special characteristic. I hope I didn't just lose you with all that explanation. If I did, welcome back. We found you. Here we are. We're going to do example 5. Excuse me. Let's say we've got x squared plus 4x minus 12 equals 0. I'm going to solve this by completing the square. The first thing you may notice, I don't know if you noticed this, I'll show you in my little notes here, but this is the first problem that we did. So we know that our thing needs to look like this. Or when we did it last time, we found that in order for this to be a perfect square, this needs to be a 4. Well, we don't have that. This is not a 4. This is a negative 12. That's a problem. That's in our way. So we need to adjust that. So that's going to be our first step here. Is, first of all, we got to get rid of the constant that doesn't work for us. So I'm going to add 12 to both sides. Now, on the right side, 0 plus 12 is just 12. That's pretty straightforward. On the left side, negative 12 plus 12 is 0. And that means then that I've got all this stuff, x squared plus 4x, and this is gone. Excellent. So now we have this situation where we need to fill in. Well, this is what we were doing on the previous page. We need to know what goes here. So to find that, we take this number, 4, and I'm just going to write it off to the side. We divide it by 2, and we square it. So that was 2 squared, which is 4. So I'm going to add, all right, I want to make sure that the way that I format this makes sense. So I'm going to add 4 to both sides, x squared plus 4x plus 4. And what I do to one side, I do to the other. Cool. Now, the second thing I had you do once we made this a perfect square trinomial was factor it, right? So that we had a binomial squared equals, well, we're going to now set it equal to something, but we had a binomial squared. Now, on the right side, 12 plus 4 is 16. That's pretty straight arithmetic, no big deal. But on the left side, we have to factor it. Remember how we did that? We took the square root of the first term, which was x, the square root of x squared, which was x, and then we took the square root of the last term, which was 4. Square root of 4 is 2. So we put an x and a 2, and then we said, hey, we're going to use the linear sign. In this case, it's plus. So now we've gone from having this thing up here, x squared plus 4x minus 12 equals 0. We've gone from having something that's not a perfect square trinomial to something that is a perfect square trinomial equal to a number. And then we factor that, so we now have the factored form equal to a number. And here is the whole reason we did this. All of this whole thing, all of these steps is building so we can do this and take the square root of x plus 2 squared. And what you do to one side, you do to the other. This means that x plus 2 equals plus or minus 4. And I know right now you're like, what? Let me back up and explain. When I take the square root of something squared, essentially the root and the exponent cancel and just leave me with whatever underneath the root sign. That's what happened on the left. On the right, I took the square root of 16. Now, when you introduce the square root sign, you have to consider both the positive and the negative roots. Think about it. 4 times 4 is 16. Negative 4 times negative 4, also 16. No two ways about that. That is just the way it is. So what we'll do here is set up two things, and I'm trying to organize this as best I can. What we've got here is x plus 2 equals 4, and x plus 2 equals negative 4. It's kind of a throwback to the absolute value, except you don't have to check these. They'll both be right, I promise. So I'll subtract 2 here. 2 minus 2 is 0. X plus 0 is x. 4 minus 2 is 2. So x equals 2 is one of my answers. Over here, I will subtract 2 as well. That doesn't change. 2 minus 2, again, 0. X plus 0, again, x. This time we have negative 4 minus 2. Please do not tell me it's negative 2. If you borrow $4 from me and then you borrow $2 more from me, you owe me $6, and I better get paid the next time I see you. Thanks. I'm just kidding, guys. So x equals negative 6. And that is how you solve by completing the square. I hope I didn't just blow your mind. I hope that you can go back and look at this. I'm going to go ahead and do the remaining 3 examples, but now that I've explained a bunch, I'm probably going to go slightly faster. All right. So let's do this. Example 6. Let's say we have x squared minus 8x minus 9 equals 0. First of all, get rid of that pesky constant that doesn't work for us. Put it to the other side. So I have x squared minus 8x, and that will equal 9. Remember, this is a big 0. Then I need to complete the square. So I'll take this number, negative 8, divide it by 2, and square it. I get negative 4 squared, which is positive 16. So I now have x squared minus 8x plus 16. And what you do to one side, you do to the other. So I will take the 9 and add 16. And then I will factor. So to do that, I need to take the square root of the first term, which is x squared. The square root of x squared is just x. I hope you've noticed that that has not changed in all of the problems that I've done. Then I take the square root of the last term, in this case 16. The square root of 16 is 4. So I got x, I got 4. So when I factor this, I'll put an x in the front, a 4 in the back. I use my linear sign. In this case, it's minus. And I'm squaring that. And then that will equal whatever 9 plus 16 is. It happens to be 25. Then I can take the square root of both sides. So I'm taking the square root of x minus 4 squared. I'm taking the square root of 25. On the left, all that happens is the root and the exponent cancel. That leaves me with x minus 4. On the right, the square root of 25 is positive or negative 5. So I set up my two equations. All right, I'm going to do it over here. I'm just trying something, I guess. So x minus 4 equals 5, and x minus 4 equals negative 5. I will add 4 to both sides here. Negative 4 and 4 is 0. X minus 0 is x. On the right side, 5 plus 4 is 9, so I have x equals 9. Second equation, x minus 4 equals negative 5. Once again, I will add 4. Please note, you will always solve them the same way. And the left side is always going to do the same thing. The numbers are going to become a 0, x minus 0 or x plus 0. Either way, it will end up being x. What will change is how you handle the numbers on the right. This was positive 5 plus 4 that gave us positive 9. This is negative 5 plus 4. This is like I owe someone $5. I pay them 4. Now I owe them $1. So my answer is going to be 9 and negative 1. That one went a little bit faster, a little less explanation. I'm trying to use a little less space. There are not a whole lot of ways that I can see to make this a little bit shorter, but I'm going to try, I guess, maybe, on the last one. I got 2 more I'm going to do for you, and then I'll let you go. So we've got example 7. Excuse me. I apologize, these notes are so long. But they're important. It's important that you see them. So we got x squared plus 8x minus 20 equals 0. So let's cancel the 20. Negative 20 plus 20 is 0. That leaves x squared plus 8x, and that will equal 20. Then we complete the square. So I'm going to take 8. I'm going to divide it by 2, and I'm going to square it. That's 4 squared. That's 16. So I'm going to add 16 to both sides. Then I'm going to factor on the right side, 20 plus 16 is 36. On the left side, I'm going to factor. I need to take the square root of the first term, which is x squared. So the square root of x squared will be x. I need to take the square root of the last term, which is 16. The square root of 16 is 4. So my factored form will be x and a 4 and a squared on the outside, and then use the linear sign. In this case, it's plus. So I have x plus 4 squared equals 36. Then I can take the square root of both sides. On the right side, that's going to give me plus or minus 6. On the left side, that just gives me x plus 4. So my 2 equations are x plus 4 equals 6, and x plus 4 equals negative 6. So I will solve these by subtracting 4. Both of them will be solved that way. So I subtract 4 here. I got x plus 4 equals 6. I subtract 4 from both sides. On the right side, 6 minus 4 is 2. On the left side, 4 minus 4 is 0. X plus 0 is x, so I get x equals 2. Then I have the other equation, x plus 4 equals negative 6. Once again, I will subtract 4 from both sides. On the right side, negative 6 minus 4. This is like borrowing $6 and then borrowing $4 more. That means you owe somebody $10. And I made my negative sign very low, so I'm going to raise that up a little bit so that it looks like a negative sign. On the left side, 4 minus 4 is 0. X plus 0 is x, so I get x equals negative 10. Now, as I was doing this, it occurred to me that it might be helpful to just kind of label what I was doing each time. So when I was solving, these were my steps. Okay, so the first step was to cancel the constant. right? So that put me here, and then I completed the square, right? That was the next part. That's finding that constant that you can add to both sides. Then I factored. Then I took the root. Then I set up my two equations. And the last thing was I solved. So I guess it's about 6 steps or so. Truth be told, we could probably argue that. We could probably condense it down. Some of you could make an argument that we could expand it. I don't know. Let me do one more example. I'm going to streamline this as fast as possible, as much as possible, so you can see what the most minimal amount of work is that I would accept. By the way, I don't know if you caught on, but all I'm doing are the examples we did off the previous page. Because, yeah, you know, they're there, so might as well. Let's see. Interesting. This last one is not going to be off of the last page, I don't think. And I have reasons for that, but don't worry about it. So we're going to go x squared plus 4x plus 3 is going to equal 0. So I would subtract 3 from both sides. I get x squared plus 4x equals negative 3. This is a 0, by the way, right there. All right, then I need to complete the square, right? So 4 divided by 2 squared is going to be 4. So I will add 4 to both sides. And I will take the square root of x squared, which is x, and the square root of 4, which is 2. Now I will factor. So I've got x plus 2 squared. And then on the right, negative 3 plus 4 is 1. I square root both sides. And I get x plus 2 equals plus or minus 1. So I've got x plus 2 equals 1 and x plus 2 equals negative 1. Let's solve both of these by subtracting 2. I get x equals negative 1 here. Subtract over here. I get x equals negative 3, and I'm done. That would be about the bare minimum I would accept, I think. So I would not plan on doing any less than that. Some of you are going to try. Please don't. That's how much work I feel is the absolute bare minimum. That's how much you need to have at the bare minimum. These are negotiable. If you just want to show me that, maybe that's the bare minimum, I guess. Because there are some people that can go ahead and figure out this number in their heads and can go ahead and do the square roots also. If you can't, that's okay. I don't want anyone to feel like they need to be pressured to do anything or to skip out stuff. I will be the first to say, when I was in college, especially, I drove my professors nuts because where everyone else would do 2 and 3 and 4 steps at once, I would do 1 step at a time. And in college, when you're doing college level math, one problem can take 2 or 3 pages back and front, just generally. So for me, it was 4 and 5 pages because I was taking it so slow. But I had to because that was the only way I could understand it. Anyway, I turn back here just so you can see the first one I did, I wrote out a lot. All of this. And I want to encourage you guys to write out whatever you need to be successful. If you have to write all this stuff out, then you need to write it out. Do not be a hero. One of the things that I've never understood about math is people complain about how hard it is, how difficult the problems are, how they don't understand what to do next, or they're not sure what they're looking at. And then when I look at their paper, they have not written down much at all. Now, they've clearly written some conclusions that they've come to, or they've done some operations and they've got some numbers and they make sense. But if you don't have the full thing out there, the full sentence for each step that you've taken, then it's like telling me you don't understand what the play Romeo and Juliet is about. And when I look at your play, all I see is like every 5th word. Well, of course you're not going to understand. You don't have the complete sentences. You know, all you have is say the verbs. So you don't know what's going on. Anyway, I've belabored the point long enough. I apologize that this video is so long. Some of you may skip through it. I will also put just a PDF of the examples up next to this video. So if you just want to copy them, you can do that as well. I will see you in class. Bye.